Besides handling the wastewaters that come from our buildings, our residences, and our commercial buildings as sanitary discharge, we also have to handle the stormwater that falls on the sites that we develop. In this case, it's rainfall. In most cases, falling on roofs and the surfaces that we build on and create what we would call non-permeable surfaces. So that's roofs and parking lots and sidewalks. All of those things affect how much water can be absorbed into surfaces. So here we have a graphic of a combination or a visual of both systems. So we have the private sanitary sewer lateral coming into our sanitary sewer system. And we have our stormwater system, a separate system to collect all of the rainwater and other water that falls on the site into a system that's discharged many times into a natural ecosystem. So in many cases in urban environments, we're fortunate enough to have both of these systems, but as we've looked at with the rural areas, we need to create sometimes private septic systems. We also need in rural areas or undeveloped areas to create retention systems for our stormwater. So here's just a one kind of an illustration of this idea that kind of, I guess, illustrates a couple of the concepts. So, the general thing is we're in a relatively natural ecosystem. We've placed a parking lot up here that's going to create runoff because the surface is impermeable. It can't pass moisture through it. So that's going to go into a system, into a stream. In this case, the stream has now been weired off or dammed so that it can retain more water. And it has the opportunity for doing some kinds of treatments to it. But in really strong events, it can also just overflow to discharge large amounts of water. But it just starts to illustrate some of the concepts of the handling of the water and a connection between where this water is coming from and its eventual collection into our natural environment. And that idea of things ending up in our stormwater and things that go down these drain systems ending up in our natural environment are many times indicated by these castings that have fish statements that they discharge to waterways. So things come off of vehicles, pollution, acid rain. There's films that form on objects from just the air, and that first flush runoff sometimes can be relatively toxic. So there is always this idea of trying to give a treatment or a pre-treatment to it before we discharge it to the natural river or stream. And even pesticides and fertilizers that are added to our soils can end up concentrating into our waterways in ways that aren't beneficial to the environment. One of the things that makes it interesting and exciting for architects to participate in is there's a lot of places where interventions can be created that make both enhance our local environment and protect our waterways. So in this case, I have an illustration up here of a large parking lot, but it's covered or surrounded with greenscaping, and that greenscaping is designed so that it collects the rainwater, it detains it, it allows some bioremediation of it through some natural processes, but it also then creates an urban buffer between the streetscape and the parking and can become a visual enhancement. And also these things can have permeable paver systems. Porous concrete is one type of material that allows water to be collected in the soil naturally, that can retain that water a while and delay its discharge into our treatment system. So there are many ways to manage these ideas of what's called first flush runoff, the pollutants, and the large amounts of water that would typically overrun our sewer systems during storm events. And in dense urban areas, we really run out of capacity in many municipalities to handle the stormwater. And one of the codes or the requirements for reducing that discharge are continually increasing. So here we have the idea of these vaults, which are open spaces dug into the ground that can contain large volumes of water during a rain event. Probably what's happening in this illustration is a parking lot is going to be created above this. So the runoff from that parking lot can be held into these culverts and then slowly discharged into the stormwater system. so it isn't inundating the system, during a large storm event. But there are lots of opportunities. This is hyperlinked, and I'll go to that at the very end, to a really well-developed building code site by one of the cities in Philadelphia, I believe it is. But these are great illustrations. Here's the connection of the the runoff from um, the roof system, ways of handling that and managing it. Here's a great illustration in that same document of this idea of a retention area that has a lot of both benefits for retaining, treating the water that comes off of parking lots and the non-permeable surfaces. Creates a nice buffer between those two areas and just really overall enhances the environment. And you can further that to all kinds of scales. In this case, we have some roof runoff that's being treated in a device that can serve as a planter and also a building buffer between the facade and the parking lot. And this can be carried on to larger and more elaborate schemes. So here we have larger parking lots with a detention pond or a marshy area, allowing for bioremediation or treatment of the water that comes off of the parking lot. And these become natural and beneficial enhancements to our environment, our site that we develop. And I did want to take you back and click on this just to show you this link. It is Philadelphia Water Department, and they talk about stormwater management practice guide. So they have all the regulatory requirements in this one. And I thought this really a delightful, as far as building codes go, read for all of the opportunities to look at interventions that you can do as a designer to both meet the code and increase the quality of the building development that you're going to do.